Let's go to the solution stoichiometry. Like all of what we learned in the solids, we had mole stoichiometry. In gases, we had gas stoichiometry. Of course, in the solutions, we have solution stoichiometry. What we need in solution stoichiometry, guys? We need chemical equation. We should be balanced chemical equation, or they should give me enough information to be able to write down the chemical equation and balance it. So I'm gonna tell you how different types of them, how to solve them. Type 1 question in the solution stoichiometry. So let's read this question. If we have this much liter of hydrochloric acid with a concentration of 0.1234 molar of basically again hydrochloric acid, which is neutralized by 0.2345 liter of calcium hydroxide, what is the concentration of the base? So in this type of question, guys, if you pay attention, they give us one, basically molarity, and which is associated with its liter of this one compound. So they gave us, if I abbreviate it, they gave us basically 0.0250 liter of 0.1234 molar of HCl, right? If we read the question. So read the question, guys, several times. And also they gave me the liter of CaOH2, but I asked for the molarity of the CaOH2. This is basically what is the abbreviation. I recommend you to do that. So they ask for concentration. This is a type 1 question, guys. They gave us molarity and concentration and liter of one, and or molarity and the volume of one, and the liter of another one, and ask for concentration of the another one. So in this type of question, when they ask for concentration, we always start with the volume of the compound that we have more information on it. What does it mean? So let's go back to the abbreviated one. Which of these, HCl or CaOH2, I have more information on it? Of course, HCl. On HCl, I have a volume and molarity of it, right? I have more information. So I'm gonna start with the volume of HCl. Okay, volume of HCl. So I'm gonna start with the volume of HCl. Then I need to, guys, expand the molarity of it. How I expand it, guys? We know that molarity is what? What is a unit of molarity? Is mole per liter, right? Molarity was mole of solute per liter of solution. So we should expand this. Why? Because I need to use it in the equation that I'm basically doing. So 0.1234 molarity is 0.1234 mole per liter, or how we can use it in unit conversion method, 1 liter over 1.1234. I just flipped it. Do you remember? I just flipped it. I just expanded it to mole per liter. So I start with it, with the what? What I said, with the volume of HCl. I put, which of these I should put here, guys? The left one or right one? I should use the left one because it should cancel out with the previous nominator. Then I get with the mole. I go with the mole of HCl. Then I can use the Coefficients. What should I use in a stoichiometry? Of course, I should use coefficients in the chemical reaction. I relate HCl to calcium hydroxide. 2 mole is the coefficient 2 of HCl to 1 mole, which is the 1 coefficient of calcium hydroxide. I come up with the number here, and that's gonna be mole. Make sure, guys, here I just want to kind of give you a hint. Always make sure don't round until the end of your question. I just put the placeholder here that I know I have a 3 sig fig. Why do you think, guys, here I have 3 sig fig in here? How I know which is my sig fig? Which one is gonna identify my basically significant figures? The smallest number of sig fig in the question. So if you look at here, I have 3 sig fig here, 4 sig fig here, and 4 sig fig here. So this 3 sig fig is my 3 sig fig. So I will have 3 sig fig at the end. Then in the second step, I will find the molarity of the concentration of the CaOH2 by dividing the mole of it that I got from here by the volume of it. Do I have a volume of CaOH2? Yes, I have a volume of it. So I divide by the volume of it and I get the molarity of CaOH2. Make sure, guys, if you do not have the liter and you have a milliliter, make sure first convert to liter and then do the calculations. Make sure first, here we were lucky, we had a liter, but if it's not, make sure convert to liter and start the calculations. And my final answer has 3 sig fig. Okay, let's go to the type 2. Here, again, they gave us volume and the molarity of H2SO4, but they gave me molarity of NaOH and they asked for the volume of NaOH. So in this type of questions, when they ask for volume, it says how many milliliter. When they ask for volume, we do it this way. Of course, again, we start with the one that I have more info about it. Which one I have more info about it? Of course, H2SO4, because I have the volume and molarity of it. I start with the volume of it. I will expand the molarity to mole per liter, and then I put it in 2 ways because I want to use it in the unit conversion method. Then which one I should use here? I should use the left one. Why? Because it should cancel out with the liter of the previous nominator. I come up with the mole, then what should I do? I use the chemical equation to relate the 2 compounds to each other. 1 mole of H2SO4 is from the 1 as a coefficient, and 2 mole of NaOH, which is 2 from the 2 as a coefficient of NaOH. Then, am I done here? No, it's asking for how many milliliter. I have another molarity here, guys. Then we're gonna basically expand the second molarity again, which is gonna be here, of course, 1.25, of course, 0.125, and I expand this. So it's gonna be 0.125 over 1 liter or 1 liter over 0.125. So which one I should use here, guys, in the continue? I was here, right? I just used the stoichiometry to find the mole of NaOH. Then I should use the right side here, guys. I use the right side, I find the liter. But it's asking for how many milliliter. So I'm going to convert the liter to the milliliter. I should make sure I follow the 3 sig fig rule here. So this is, guys, the second type of question. This is, guys, how I basically categorize the solution stoichiometry. Of course, if you have another way and you get the same answer, I'm okay with that. Okay, guys, let's go to the type 3. Of course, limiting reactant. So how we cannot do the limiting reactant? All of the stoichiometry has the limiting reactant in it. So of course, in limiting reactant, they gave us 2 given numbers. So they gave us all of the information we need for them. So they gave me here 150 milliliter of the HAgNO3 and 0.500 molar of it, and they gave me 100 milliliter KCl and 0.400 molar of it. So they give me in the limiting reactant question everything that I need of a given numbers. So what I need in molarity calculations, the volume and molarity of the compounds. What else I want? Nothing, right? So what should I do? I do just a limiting reactant, like other limiting reactant questions. I relate each reactant to the product. What product? The one that is basically giving one. They already asked in the question. They already basically asked in the question. So let's do the question and tell you what. So how many gram of this? So I have these 2 given numbers, and they ask for what? How many gram of silver chloride will precipitate? So they ask to compare each reactant to AgCl. So you're gonna relate each reactant to AgCl. Why? Because they gave me in the question how many gram of silver chloride will precipitate. So I should find the theoretical yield basically. So you're gonna start again with the volume. Always, as you saw here in a stoichiometry, I start with the volume basically. So then I'm gonna start with the volume. Doesn't matter which one you start with first. I choose to start with AgNO3. Why? Because I like it, right? Okay. So I'm just kidding. Okay, I start with the volume of it. I just converted it to liter first. Then I will expand here my molarity. Which one of these I should use? Left one. Why? Because it should cancel out with a previous nominator. Then I find the mole again. I'm gonna use the chemical equation. I'm lucky is 1 to 1. Make sure, guys, check it with balanced chemical equation. Is 1 to 1 ratio. Then I will convert to the gram because it's asking how many gram of silver chloride. Then I find the 10.6 gram of AgCl. Am I done? No. I should go with the other reactant. So I'm gonna use again start with the volume, convert to liter first, then I use a molarity, I expanded it here. Which one I should use here? Left one. Why? Because the unit should cancel out the previous unit. Then I use the coefficients to relate to product, and again convert to gram of the same product, and this one will be 5.68. So which one here, guys? It will be limiting reactant. Of course, is not AgNO3. So which one is limiting? Is KCl. KCl is here, is limiting, and 5.68 gram HCl is my theoretical yield. Okay, so of course 5.68 gram is my limiting reactant. Of course 5.68 gram of AgCl is my theoretical yield. Of course, guys, 5.68 gram of HCl is my theoretical yield and KCl is my limiting reactant. Why, guys? Because it's producing the smallest amount of product. Okay, let's go, guys, to some sample questions. I have more questions as a worksheet on platform. Make sure to do them. It's very helpful. An adult consumes 3 gram of sodium per day. How many gram of sodium chloride solution he consumes every day? So they already gave us the mass of solute, and that's the basically percent of sodium chloride solution. So what I'm gonna do, I'm going to basically put the mass of solute with 3.1 gram divide by mass of solution, and here is my 39%. So of course known side divide by the unknown side, then this is going to be the 7.9 gram of NaCl solution. And makes sense, guys, because we said that the solute amount should be smaller than the solution, and makes sense. You can always use this method to make sure if you got the correct answer. So determine how many gram of sucrose are contained in 1.72 liter of solution. Do you think, guys, which type of question is that? Is molarity question. So is N equals to MV? Of course. So N equals to, make sure it should be in liter, and then I convert it to gram of a sucrose. Make sure you follow the correct number of sig fig. Let's go to the last one. A stock solution of 1 gram NaCl is available. How many milliliters are needed to make 100 milliliter of 0.750 molar of this solution? Make sure, guys, you might ask how I know this is the dilution question. Of course, it's a dilution question. How? They always give you, guys, in dilution questions one compound. So it means should kind of relate the compound to itself. You know what I mean? And in dilution question, we do the same. So in the both sides, we have the same compound in dilution question. So in dilution question, they always give you one compound. This is how you know this is the dilution question, or M1V1 equals to M2V2. So we're gonna put the one, make sure that you know which side is concentrated basically make sure don't mix them up. So you should make sure, if you remember, I said that when we say 2, it means we should write down the second side, right? So here is 1 molar, we need V1, and this is the second side. And here is going to be how much this of a stock solution of NaCl we need to make the 100 milliliter of this solution. So it says how many liter of solvent should be added. So we should subtract the 100 milliliter minus the 75 that I got here. This is 25 milliliter, but it says liter. So I should divide it by 1000 to get it. Basically, it's going to be 0.0025 liter of water should be added. Okay, let's go to another one. How much of 0.125 molar NaOH solution do we need to completely neutralize this one? So here is what, guys, type 1 question, right? So because it's asking for the how much of this is asking for the volume basically here. So that's a type 1 question. So we start always with the liter of the one that has more information. So I start with the liter of H2SO4, and then I use the molarity of it. I convert it to mole. I expand the molarity, I convert to mole. I use the coefficient to convert to mole, and then I use the second molarity and I expand it. It's the second molarity and I expand it to find the liter of the solution. That's a type 1 question, guys. So there is another way, guys, to do that. This is method 1, just type 1 question. I give it a second way. The method B, guys, is also kind of like a Boyle's law that I talked about. Like we have one side and we have another side. But in this question, we should put the one side acid and one side base. So MAVA equals to MBVB. So for solving basically a stoichiometry questions, there is another way to do them. I did not do that until here to tell you that I accept this method in the exam, but if you go to higher levels of chemistry, the instructor might not accept this way. They might tell you should show me the stoichiometry way or using all of the steps. So pay attention, guys. This is not the way that all the instructor accept. So MAVA equals to MBVB, and you see there is a B as a coefficient here. This B, guys, is the coefficient of the base in the chemical equation. So the coefficient of the B goes here, and the coefficient of the acid goes in the other side. It's very important, guys. You should always put the coefficients here. If you don't put, your answers will be completely wrong, because you should include the coefficient of the acid and base here. If the coefficients are 1, you are lucky. It might not be wrong. But if your coefficient is not 1, you should make sure that in the side of the acid, we should use the B coefficient. In the side of base, we should use the acid coefficient. So let's do the same question. So I know that I have my acid side here is 0.175 liter, and 0.225 0.175 molar and 0.225 liter. And what is the coefficient of the base? Is 2. I put it next to it. Then I know that the molarity of the base is 0.125 and we need to for it. So I'm going to put 1 here because the coefficient of the acid is 1. And when I do the calculation, that would be the 0.630 liter. So it would be the same as this one, guys. So you can also use this method to check your answer, basically. You know what I mean? Okay, guys, this question is also type 1 question. Again, it's asking for how many milliliter of barium nitrate are required to all the ions uh, be precipitate from this aluminum sulfate. So I abbreviated here, guys. So what we're gonna do, we're gonna start again with the liter of our the volume of the compound that I have more information, which is aluminum sulfate. So I use my molarity, of course, to find the mole. Then I use the coefficients to basically oh, 1 Okay, guys, we have also the second one, a type 1 question. So they gave us molarity and volume of the aluminum sulfate, and they ask for the milliliter of barium nitrate with the molarity of 0.250 molar. What should I do, guys? I should start with the volume of aluminum sulfate. Why? Because I have more information on it. So I'm gonna start with the volume of it. I connect it to the mole of it, use the molarity. I expand the molarity of it to convert to mole. Then I use a coefficients to basically relate the aluminum sulfate to barium nitrate. Then I use the molarity of it to molarity of barium nitrate to find the liter of it. I want you also to do the method 2 and see if you can find the same volume using the method 2 for the question 5. Okay, so let's go to one limiting reactant question and we will be done. So how many grams of silver bromide will precipitate? So they gave us the given number of volume and the molarity of all the reactants. So that's the indication that I have limiting reactant. And of course, is asking for how many grams or is asking what's a limiting reactant. So, or what's a theoretical yield. All of these is the limiting reactant question. So what should I do, guys? I should relate each reactant to AGBR. Why AGBR? Because it's telling us how many grams of silver bromide will precipitate. It's basically asking for theoretical yield here. So we here first start with the Ag2CO3. Why? because of course I like it. No, I'm just kidding. So then I relate it with the molarity of it, and then I relate the I made a mistake, to 2 mole of AgBr, because it's 2 here, the same here, 2 AgBr. And based on the calculations that we did, MgBr2 is our limiting reactant here because it's producing the least amount of product, and 16.2 gram is our theoretical yield. So it says in the question how many gram of silver bromide will precipitate. So we should, by emphasizing that 16.2 gram AgBr is our theoretical yield, is actually this much of AgBr is produced in this reaction, uh, based on uh, the paper calculations. So that's all for this concept. And please do the worksheets that I uploaded on the platform.